Hey, classes, welcome back. When you check out the pictures that are on the board behind me, I'll turn this off in just a sec, but I had a couple things to remind me and remind the classes about what we've seen. We're starting to kind of review for the final now. We're going all the way from where we've been to where we are right now over the last 34 weeks. It covers a lot. I'll give you guys, of course, a final study guide, but for current events today, I use something a little bit different, a clip of an upcoming movie, Oppenheimer. At the very beginning of the year when we were talking about atoms, how atoms are put together, for example, and if you look, for example, at the pluses, the positive charges that are in the nucleus, one of the things that sometimes, now that you're in middle school, students start to look at the board notes and say, hey, wait a second, I know positive charges don't like each other, neither do negative charges. Like charges repel. One of the things that hopefully we were learning as we were going through the four fundamental forces of nature. Why would an atom look like that with all those positives close together, all those negatives close together? Turned out there was another force, and they figured this must be a very, very strong force holding the atom together. So, of course, they called it, well, the strong force. But if you look at the strong force holding it together, that led to the whole idea about how can you release all of that energy all at once. That also led to us learning a little bit of local history. For example, if you're looking at some of the local history right here, that it ended up leading to, there's Tan Fran. Now, you don't think of Tan Fran as being an internment camp, but that's what it was. It was a racetrack at one point. When you go into Tan Fran, it was a local tie-in as well because we talked about where the BART station was. When you go to Tan Fran, they always show the pictures of the horse track that used to be there. It was very famous for that. But it wasn't Japanese internment camp. Japanese Americans were interned there during World War II. And that led us to talking a little bit about Manzanar, which is a place out there in the Eastern Sierra. In this class, we learned about how those Sierra were formed. We also touched on the history of the Americans that were unfortunately put in camps on the eastern side of the Sierra, and how those all local history, all local tie-ins that has connections. Over the course of the year, for the last 34 weeks, things hopefully are coming together like little pieces of a jigsaw puzzle. There's been a lot to cover this year. If you look at the 7th grade standards, it goes through a little bit of math, a little bit of conversion factors, a little bit of atomic theory, DNA, amino acids, proteins, carbohydrates, all the way to plate tectonics. It's like a mile wide and an inch deep. One of the things that we're trying to do, especially here at the end, is bring it all back together. The last little thing before I turn off the screen, that's why I have this one down here, conversion factors. You'll notice it started here with pesos per liter. You end up with dollars per gallon. And one of the things that you'll see in your book, and that is this CPM book. This is the 7th grade CPM book, course 1, 2, and 3. On this particular book, I believe if you look at, let me look over here, page 426, they talk about conversion factors. Specifically, they call it the giant one. We'll get to that in just a second. But it's simply a way of getting the units that you want and the final answer that you want. So a quick recap of the notes today, and again, look for these online. But as I move over my clunky board here, we get, at the very, very beginning, the current events. Again, use the Oppenheimer trailer for the movie. See Matt Damon again. Matt Damon pops up. He pops up like 3 times in this class. In this case, Matt Damon pops up. He's an actor in the Oppenheimer movie. We saw him at the very, very beginning when we used, and I'm talking September now, we use a little bit of clips of The Martian. You might remember The Martian, Matt Damon, Mark Watney, stuck on Mars. Well, in this case, he's popping up again here in the Oppenheimer movie. That led us into understanding the 4 fundamental forces of nature. Again, the 7th grade standards talking about how atoms are put together, how atoms combine to form molecules. Molecules can link, make polymers, that sort of thing. When we learned about amino acids. Also, we learned about the fundamental forces in nature because when we go through radioactive decay, one of the things that keep the inside of the Earth hot, well, the radioactive decay is made possible courtesy of the weak force. And so you're looking at starting the year with atomic theory, how atoms work, because it's critical to understanding not only how our planet works, but our planet's working. For example, the heat inside generated by radioactive decay, makes plate tectonics possible. Plate tectonics, critical for recycling Earth's materials. Also critical for evolution. It brings species together, separates species. changes the climate by changing the way that oceans circulate, for example, and changing weather patterns. So again, looking at the tapestry, looking at the jigsaw puzzle that is this year, and again, look for the study guide for our final exam. Our final exam is still 2 weeks off, so we'll check that out. From there, we moved on to, my board's a little clunky here, sorry about that. We moved on to our key terms for the week. On our key terms for the week, one that we kind of are sneaking in here is calculus. When I was coming home just a couple of days ago, listening to the Giants baseball game. The Giants hit a home run. They beat the Brewers that particular night that I was listening to the game. And when the announcers, when KMBR was talking about the home run StatCast, they gave the exact distance of that home run. Now, why did I mention that? Well, with a little bit of algebra, you can calculate that fairly straight. It's fairly straightforward. You've got the gravitational constant here on Earth. You've got the mass of the ball, which isn't changing. It's a constant mass. And you've got, nowadays, the speed with which the ball was pitched and the launch angle, the trajectory. When you put those together, you use a little bit of algebra. You can figure out exactly, even though it went over the fence at, say, 385, you can say, well, that one traveled 393 feet. Forget which one, how far this one went. When you're talking calculus, and this is a little bit of a plug for taking the hard math when you get to high school and beyond. My rocket model is over there, so this will be my stand-in for my rocket right here. If you took a rocket and it's taking off, again, we're watching little clips from the movie Hidden Figures right now, and the reason we're checking that out is, of course, we in this class are focusing on the math of the movie, but of course it takes place against the backdrop of the civil rights movement in America. So you can't ignore the history in terms of, you can't separate the two. It's all part of the story of the people that made possible the moon flight, but also the social struggles that were going on in the 60s and are still going on right now. But when you're talking about the math, about the hidden figures, if you will, the double entente in the movie, when you're talking about the math of a rocket going up, it's not like a baseball. It's not like a baseball going over the fence to win a Giants game in this case. You're talking about the mass not being constant. As it's burning its fuel, it's getting lighter and lighter. And as the rocket is moving, it's going faster and faster, unlike a baseball, which is on a parabolic trajectory. On the way up, it's slowing down. Here's the point. You can think of calculus like algebra on the move. Algebra is about taking variables, plugging them into some static equation, whereas calculus is sort of like dynamic algebra, which is really awesome. Encouraging you to take those math classes when they come up. Getting back to the algebra, again, all of the things we're doing right now are taking us all the way back to the beginning of the year. But if you look at one of our equations, I said if you go back on one of the YouTube videos, you can see that we were going to have, going into this year, only a handful of equations, 5, 6 equations: speed, distance, time, density, mass, volume, pressure, force, area. All of those equations, if you look at the equation triangle we have on the board, all of those equations really are just 3 variables. And in the case of giving students some practice with the speed, distance, time equation, we have the equation on the board, something that will help you out every single time you come across this in chemistry in high school, in physics in high school, physics across the hall over here when you get to 8th grade. You're talking about putting the equation in the form that you want. So speed, distance, time. Well, I was challenging the students to figure out, okay, if there was a bridge to the moon, how long would it take you at your current mile time? They just ran the mile out here with Mr. Bolter and the PE crew outside. If you look at time, distance, speed, that's the form of the equation we want. How long would it take you, given the distance to the moon and your particular running speed? If you notice we're using miles, we don't use miles all that much, but we are for this one because you guys ran the mile, not the kilometer, but the mile. When you're looking at plugging in all the numbers, 1, we write the formula. 2, you just plug in the numbers. And 3, the one extra thing we wanted to mention is like, okay, 250,000 miles, 7 minutes per mile. You're going to get an answer here in minutes. That's not really the way you'd express something that would take many, many days. In other words, it would be a very large number of minutes to write down. So that's where you get the tie-in with the math class. The big one And I put that in quotes because that's what this particular textbook calls it when you have a conversion factor. They put a giant number 1 over it. They kind of superimpose a big number 1. Why would we multiply it over 1 hour versus 60 minutes? Remember, the math, when you multiply something by 1, you're not changing the value. So we're multiplying it by a conversion factor to get to the units that we want. When you look at 1 day over 24 hours, they're the same thing. If Miss Eifert says, hey, we're running the mile today, and everyone says, oh, I don't want to run the mile today. And so Mr. Sewell comes along and says, no, 7 mile, tell you what, we'll run 5,280 feet. Everyone's like, hey, that sounds better. It's the same thing. 5,280 feet is a mile. They're the exact same thing. That's called a conversion factor. Again, use them because when you're multiplying by 1, you're not changing the value of your answer. You are changing the units. Again, one of our key terms up there this time. You are changing the units that your answer is expressed, in which your answer is expressed. And so when we're looking at math and the way it's used in science, remember, math is the language of science. And one of our intentions up here, if you look again back all the way to September, these cycle back to things that we saw way back in the first week or 2 of school when we started learning a little bit about Cartesian coordinate system, conversion factors, and how you express your answers in a science class. Hope that's a good recap for you guys. Remember, the notes are up here online. Remember, our key concepts are, as always, due at the end of the week. And finally, don't forget your engineering slideshow. We have a little bit of extra time to finish that, but make sure, please, you get that in by Friday. Take care of yourself. Have a good week 34, and I'll see you here in class. Bye.